Okay, boys, we're going live.
Is that us?
We're live. You can start talking.
Okay, folks. Hi, everyone. My name is Boris Levanov, and I'm one of the hosts for this evening's DevOps Playground session. Before we kick things off, just a little background on the Playground. Started back in 2015, this humble community has grown from 10 users to over 5,000 worldwide, so thank you for supporting the Playground by joining us here tonight. Our aim has always been to provide a platform to share and collaborate knowledge amongst all our members, and we do this by running a monthly technical hands-on session with some of the emerging and popular DevOps tools. The good news is each playground is run by a qualified ECS engineer, so you know you're in good hands. For those who haven't heard of ECS, ECS is an award-winning digital transformation consultancy. We adopt agile and DevOps techniques to rapidly upskill teams, accelerate release cycles, and drive meaningful innovation, with our skill set covering everything from cloud adoption and digital to data analytics and customer experience. ECS are also the sponsors of the DevOps Playground and are always on the lookout for engineers keen to drive real change in their work. Before we get going, remember to sign up to the Slack community channel so we can offer technical support. Apologies. Before we get going, remember to sign up for the Slack community channel so we can offer technical support during the playground and have your instance login details to hand, as you'll be needing those soon. If you need a bit more time on a particular section, feel free to pause this live session and be sure to revisit from tomorrow once it's been pushed live to our channel. And I think that's it for the introduction. James, you're on.
Thank you, Boris. As he said, I am James. I am the presenter for today's playground. It is awkward. Today we are talking about we're doing a deep dive into Terraform, and we are creating a Terraform provider for home automation. But I will go into that a little bit more. Who am I? I'm James. I started in ECS 8 months ago. I joined through the academy. I've been asked very nicely to give a quick pitch for the academy because there's a new academy happening on the 30th of September and they're looking for talented individuals. Here is a massive information about it. It's a 3-month course, which is a good way to get into the industry if you are a tech person that's just never really made it in, or if you're looking for a change of career. But yeah, that's a quick summary on that. Now onto the fun tech stuff, which we are all here for. So I'm going to break it down. I'm going to talk about Terraform quickly. Hopefully everyone knows what Terraform is, but it's always worth having a quick refresher in what Terraform is. I'm then going to talk about a bit about APIs and how that links into home automation, and then the software we'll be using, which is called Home Assistant, to manage the system, manage the home automation. So Terraform. This is the dump that I'm pretty sure every one of these that touch Terraform gets from the Terraform website. Terraform is a way of managing your infrastructure as code, but it can do a lot more than that. And that's kind of where this talk came about. Terraform is a tool that can pretty much do anything you want it to do. That doesn't mean you should. I'm certainly not advocating that you should use Terraform to manage your home automation setup. But this is a good excuse to dive into kind of the nitty-gritties of how Terraform works. As this is a core part of what we're going to be touching on, I thought it would be a good way to talk more in depth about the state. So the big thing about Terraform is it saves the state of your infrastructure or any system and can then check to make sure that state works or that state is correct, and then bring your infrastructure back to that state if any deviations happened. It does this multiple times throughout the process. Anytime you plan, it checks the state. It reads the state, it then reads the system, and then it compares them to make sure they're working. And then when you apply, it does the same. It then applies all your changes and then re-updates the state file. And then upon delete, it obviously just deletes the infrastructure and then deletes all the references to it in the state file, which normally means you end up with a very small state file. The providers, hopefully all you guys that know Terraform have seen the provider, but Terraform does quite a lot of magic behind the scenes if you're using the default AWS provider, where you don't need to tell Terraform to use the provider, but when you're calling AWS_instance, it just runs it. It just installs the provider going, oh, you're using Terraform. The way the providers work is they just use Go. It is a data object. Here is a example data structure from the code we're about to touch, where this one, it sets up the the entry ID and the state if the light is on or off, and then it sets up some methods which are when you create, read, update, or delete the infrastructure. Yeah, and then when you mess with the object, it calls some Go code and then returns the object to Terraform, which it then populates this state file. So we talked about Terraform as a infrastructure as code tool, but what it really does is what it normally does. It just calls APIs. So a brief summary of what API is: it is an application programming interface. It is a way of one piece of software talking to another. Normally, we're using stuff called REST. I suppose REST is quite an old tool. It's still used quite a lot, but there are newer tools coming out there. I think we did a Playground, I'd say a couple months back, maybe a year back, about WebGL, which is another API tool. There is three main parts to REST, which is get, post, and delete. And I mean, they kind of do what they say on the tin. Get some infrastructure. Post is you are sending a request to make something, and then delete is you're going, hey, delete this thing for me. What the backend that you're calling does with that information is up to the backend. It is just a standard. You can do what you want with it. So home automation. I hope everyone's heard of something like this. It's got very buzzwordy. So like 5-10 years ago of the, you can do everything. You can walk into your house and your light bulbs turn on, or you can, I don't know, turn your TV on and your blinds close. But it's all about connecting your system together and controlling based on certain attributes. And here's a nice little definition from Wikipedia. So this all connects into IoT, Internet of Things, which has become crazy popular in the last couple of years. It was certainly a big thing kind of almost 20 years ago now. But it's certainly coming into it now with internet, Wi-Fi, and some the big providers like Google, Apple getting on board and going, hey, here's all our Internet of Things devices that can do everything and monitor all the data. And of course, they have a nice, sexy API we can touch. To put an end to all this, so Home Assistant is a piece of software that manages your infrastructure, manages your home automation. So it's getting better now, but what it used to be was every device, every company had their own API, their own system, their own kind of walled garden, and there was no easy way of getting between them. So you couldn't have it that when someone touched your doorbell or rung your doorbell, your hue lights turned on. And this is a piece of software that tries to get around that. So basic information, it's open source. Here's the URL if anyone wants to have a go with it. I do not use this in my day-to-day life. It's something I would love to set up, but I've never truly gotten around to it. But it does what we require. It has an API, and you don't need physical devices to get your hands in and play with it. So it's quite a nice system to use. And that's the slides. Now we can get onto the demo. A nice fun thing to show you, to show that it actually works. So here is the Home Assistant UI. I have a hue bulb here, and sorry if it's going to get very bright, but if I take this box, the light bulb turns on. I know you can do this with the hue system, but this is kind of how the Home Assistant thing works. I'm now going to sit down because my laptop's a bit low. If one of my glorious assistants can lower the camera. Sorry if it gets a bit juddery while this happens. And hopefully I'm still in shot and everything is usable. We are just going to check. We are back in the office to do this. And it's a process. Let's just say that, as with all these things. So the nice README. I may slow down a little bit now as well. Maybe have some water. So in the description of the video, you should get a link to lab.playground.org. You need to enter your meetup name. I think this is just down as ECS. And you'll get your username, your password, your ID, and your terminal. So in a web browser, you just need to type in your URL and -weti, gives you a nice terminal, which we'll use to run some basic commands just to trigger the infrastructure and destroy the infrastructure. These do have Vim installed. You're welcome to use Vim if you are comfortable using it. I'm going to use the IDE, which is this other link, which is your URL -8000, just because I feel it's a little bit easier to show what's going on and where I am in the file structure. And then your password, obviously you need to log in to Weti. Okay, so let's get down to it. The README link is also in the description, and it should have all the information you need to get you going. If you can't, as Boris said at the start, there is support team on our Slack, which is also in the description. Or if you just post a message on YouTube, then one of the glorious people that assist in all these lovely playgrounds will reach out to you and we can hopefully get something sorted. Okay, so along with these other links, there's also the Home Assistant spun up, which is, here it is. If you go to URL and then it's port 8123, you should get this screen, which asks you for your set up an account. This is not HTTPS. This is not secure. This is in our own structure, and it's just to be spun up and destroyed. So don't use a secure password. I have never needed to type in a password during this process. So just put something simple, and it shouldn't matter if you forget it. I'm going to call my name Panda, and then password is going to be some unsecure password. And then we get in. So all this information is for setting up metrics and weather data and whether it's sunny. It's not stuff we're messing with. So you can just click next and ignore all these things, and you should get this screen. It may look a little bit different. I'm obviously using half my monitor for this README, so it turns into mobile view a little bit. So obviously we need to find a way. Now this is all set up, we need a way of Terraform talking to it. So we know the URL, it is this URL, 8123, but we need a access token to tell Terraform, yes, you can talk to this. So this is this API key. And to get it, we click these 3 dots if you don't already see this big bar, and then you click your name at the bottom. And then if you scroll all the way to the bottom, there is this long-lived access token. And if you click create token, give it a name. I'm just going to call it Terraform. I'm sure there is a better name to give it. Then we just copy this long token. And then if we go into, so I'm going to go into the IDE. Obviously, you can use Vim if you want. And then in this Terraform TF examples file that we will in the future be renaming, if you just put it, replace your token with this nice long string. and save it. So that's setting up the bearer token for our API calls to Home Assistant. And then I've kind of combined these two. I've kind of combined step 1 and 2, step 2 and 3. Step 3, we just need to then rename this file. And when I say rename, you just need to get rid of the example at the end. So it's just terraform.tfrs. The reason why it wasn't terraform.tfrs to start with is for security, there is a git ignore that has the standard Terraform. Don't upload vars, don't upload the state, because you wouldn't want your tokens to get out there. If you wanted to upload this, then you could store tokens in environment variables or some other way of doing it. So the next thing we need to do is we need to make sure it all works. So in Wetty, I've made a script that I'm just going to cat out. I've missed another step. We need to go into a different location. We're currently in root. So if we go into work, dr, and then this crazy long Terraform deep dive, creating provider for home automation URL. That was SH, not CD. Okay. And then if I cat build, I'm just going to cat this file because it's a nice short file. So this is a very simple file. All it does is it deletes the lock file, because as of Terraform, I think it was 0.16, they made the lock file to make sure that you're downloading the version that you think you are. We're just going to be updating the same version. So the files are going to be updating, but the version is going to be the same, which, yeah, we need to just remove that file. And then the true is don't error, just don't worry about it. We're then seeding into the provider directory. This is where all our Go provider code is. We're then building that script. I am passing some variables in just so I can use the same file for multiple builds, or if I want to change the name or the version number, this script will then work. For quick feedback, I also have it run Terraform init plan and auto apply, just because we're going to be trundling through these quite quickly. Well, I say quite quickly. Every time you mess with the provider, you want to get that seen as a change in the infrastructure. So it's worth just running all through it once. In an actual production environment, you probably wouldn't do this. You would have a bigger pipeline that can pick it up and do checks and run tests to make sure it works. But as this is just a playground, keep it nice and condensed. So let's run that file. So sh build.sh, and then we need to set our, this is the $1 variable, which is our name. I'm going to just call it funny panda. This can kind of be anything, but it's worth remembering what this is, because every time you call name, it has to be the same. Anytime you see this name in angular brackets, it has to be this value. And then call it build number. First build, I'm just going to call it 0.01. And then I'm going to run it. And the first thing it's going to do is it's going to try and remove the lock file. There's no lock file, we've not built it yet. So it's just going to give us an error and keep going. It's then going to try and download all the Go modules. I think they're called modules. Yeah, all the Go modules that we use. It's all just like, it's all the HashiCorp stuff to build the provider. And then we've got a Terraform code, so it's going to initialize correctly. It's going to go, oh, you've declared a variable, but nothing's happening. And then it's just going to run through. And we should get apply complete. Nothing's there. So let's actually get in some Terraform code. So if we go into our main.tf file, I'm going to change this so it's a little bit easier to see. And then there's a lot of lines of code, so I'm just going to be copying and pasting. If you do feel you'd rather manually write it all out and I'm going too quickly, you're more than welcome to pause the video and then play it in your own time. We're not going anywhere, and we'll always be around to answer questions. If you finish after the video, you can always just drop a comment and we'll try and get back to you or post in the Slack and we'll get back to you faster. So yeah, there is the provider. Remember to change this name to the name you set. So I called it mine Funny Panda. Okay, just let's quickly go over this code. No point just copying and pasting. You might as well try and understand what it is we're doing. So this is the kind of Terraform boilerplate. You want to create a provider. You're saying, here's the provider we want. Here's the internal name for Terraform. And then we're giving it the version number. So this is the number that we set in the that build script. And then we're doing the source where we're just putting it to GitHub if it fails. So if there's some error in this code and it doesn't work, this won't be able to go to GitHub. It's not expecting a GitHub URL like this. So if it failed because of GitHub, then there's something else going wrong. But it's good for now just as a demo because we're manually putting the file in that directory. And then we have the provider code. If you've meshed with AWS, this will normally be like provider AWS region and then region number, or you can pass in your keys. We're saying the host, it's on this machine. If this was on a different machine, obviously you change the URL to a different machine, and this is the port number. So it's equivalent to this URL. And if you put in this URL, it will probably work. We then have the token. This is the one we set up in the variable in the TF file, and it's just a way of passing it through. Now, if we run again, hopefully it'll do nothing. Yep, that didn't work. It should at least be saying the variable's used. That's a good start. Main.tf. It's always a good start when something doesn't work. Okay, so it is there. I don't 100% know why this is not seeing the token. Terraform provider, home auto. Oh yeah, I missed a step. I'm jumping ahead already. I always miss this code block. So in the variables.tf file, make sure you set the bearer token, because otherwise the bearer token is not going to be run through. So yeah, and then we need to make it sensitive. It's a token. You don't want Terraform to output it or save it somewhere that it shouldn't be. And it's good practice. So now if I run this command, it should all go through. Remember, read the README. It's important. So as you can see, this did absolutely nothing. All it does is make Terraform happy, which is good, but not useful. So let's actually get to building this provider. So I've built some very basic skeleton code because no one wants to copy. Yep. So if we go into provider and then home auto and then provider.go, that's a very basic boilerplate to make sure one, it works and builds, and then there's no need to copy and paste swaths and swaths of code. We can ignore all the fluff and just get down to the interesting stuff. So something that if you are using your own computer may do automatically. Make sure we have the import net /HTTP. Go doesn't like it if you have providers defined but not used, which is why it is set up there by default. Yeah. The next thing to do is this provider block here. We are going to copy this nice big block, and we're just going to shove here. Oh, I'd leave the comment. Let's leave the comment because the comment tells us what's going on. I think. Okay. So this is the code that sets up that little provider block that is now, in the mains. This sets up this provider block, and it kind of says what host and bearer token are. So in here, we have a schema, which is just kind of a data structure. Anyone that's dealt with databases, it's how you define the columns, or how you define what the columns are. So we have the host schema. We have the host, which is a string, and it is definitely required. You can have default functions that I think make sure it sets up correctly. This is just, it doesn't want to do anything. It needs to be there, but then there's no data processing that needs to happen on it. And then we set up base description, which can give out for, you can auto-generate docs from all of this. So the more we can fill out, the more can get auto-generated for us. Then the bearer token, it's about the same, except it is sensitive. So we tell Terraform that it's sensitive. So even if the variable is saved and the end user does things not in a secure manner, this still, to us, is sensitive, and Terraform will do some stuff with that knowledge. We then have a resource map. So if you ever open up the AWS provider, which if you're interested in providers is certainly something that is a good look into how it can be done. This resource map is massive because there is hundreds of resources. I'm pretty sure it ends up being a different file, just referenced here. And then this tells it to, when you want to run a provider, run this file, this function, which currently doesn't do anything. So I think the next step is to put something in that provider. And this just is very basic stuff. It gets the token, we check the host, and then we make sure the host is okay, that it's a string, so people aren't just putting in numbers. And then we create a client. That is the information that Terraform passes around to all the resources when it wants to deal with the provider. If we just look at the client code, I've done a lot of this code. So all this client stuff is boilerplate. Well, I say boilerplate. It's all just HTTP calls that deal with calling the REST API. As it's not really anything that we are dealing with today, I've just written it all and left it. You're welcome to look at it, rip it apart. I will come in and talk about it again when we're looking into the apply and update, kind of see how it connects to home automation. But I think the focus today is a lot more on the Terraform provider side. So all this does is in Go, it creates a data body and appends bearer to the token. So the next step, you can run the setup code again, but nothing happens. Terraform only runs the provider code when a resource needs that provider, so it's not just doing extra work when it's not needed. So if we turn back to main TF and build a light, we have a nice light here. This is kind of the smallest light you can have, which is a entity ID, which is just the name. The home automation, home assistant ID structure is the type, so light, switch, and there's a couple others, and then a name. Virtual light 10 is what I called it. This hue light bulb is just called light.go, which I'm pretty sure is just the name that Patrick, who owns this light bulb, set it up with. And the state, obviously, on or off. Do we want a light bulb or not? This could be I could have changed this to a Boolean and then just done some data processing in the provider to set it, but because it's a light, it feels more human to change it to on or off. but obviously this can be changed not too difficultly if needed. So now we have a light. Let's run the script. And I should just be able to cut. And we get a nice block of things, and oh, it's not set up. I just realized I'm probably exactly where this not set up screen is, unless I've been magically moved somewhere else. So let's see what Terraform's trying to do. So we built the file. That's good. No go errors. That is always something we want to see. Then this is Terraform init. It's going, yep, looking for the provider. It's found it where it thinks it should be, and then installs it. It kind of moves it from a global location that we save into the local file. It then creates a log file for it, and then it tries to create. So this is the light bulb. As you can see, there's a few more things that Terraform thinks the light should be, but that's just for another extra stuff down the line, and it's like 50 lines worth of code to set it up, so I didn't think it would be worth bulking down the script, and you can see more of what it can do. And then it tries to create, and we get an error because we haven't told the light what to do to set up. And I made output a nice error, which is always fun. So if we go into step 7, where we are creating the resource, let's just close some of these things. And if we go into, so this is the provider or project Terraform, provider home auto, and then resource underscore light. The way Terraform works is resource is actually called resource underscore light. I'm pretty sure there's data, which you can have as well, which is data underscore resource, so data underscore light. I just want to get rid of this, but it's not letting me. I'm sorry, my headset just decided to turn off. That's not important. That's not a good sign. Anyway, the resources light structure. So this is the this is what we passed into the provider.go. If you see here is the resource map. We're just passing in the resource light function, which is this function here. And as you can see, it's a big, chunky like data structure. So the base that you need for everything is you need to create context, read context, update context, and delete context. And if you remember from when we were talking about state file, that is the, well, the update is when you kind of plan, when you actually, you want to see, well, the read is the plan. You want to read the file and see what's going on. And then the update and create are based on the apply. If it doesn't exist, you need to create it. If it does exist, then maybe we need to update it. And the delete is, well, pave the infrastructure, Terraform destroy, or just if you remove the infrastructure. So the, yeah, I'm not going to go entirely in depth in these. Computed is obviously Terraform works out. We don't need to worry about that. So it's not really something the end user would use. And we've got the entity ID, which is required, and all these things you have defaults. So if we made a light and just gave a name, it would turn on. Isn't that useful? But maybe you wanted to just very quickly make a lot of lights. And we see some of the other things. They talk about different types. So you've got ints. Well, yeah, you've got type int. We've got type list. I'm pretty sure type lists can include lists, so you can kind of go forever, depending on how in-depth your data structures you want to be. And this is the what Terraform HCL code sees. This is the like data structure that needs to be in. So you can have a very flat data structure within Terraform that then gets turned into something very nested, or you can do something very nested in Terraform that then flattens out depending on how you want to write your provider and how the API wants the code to be in the end. They're very kind of, this is the glue that holds them together. So nothing has to be the same. Maybe it should be. You should keep some systems between them. And then we've got the functions that are what happens when things get called. So we are going to create a light first. Nothing can happen until you create it. So let's start with creating. In the context at the top, this is what Terraform sends you. If I copy the create code, we can actually see what some of this stuff is used for. So the CTX isn't used, it's just passed around. I don't know if any of this code actually uses it. I think it's more information about Terraform as a whole, which this provider doesn't touch, really. I mean, this is a very simple provider. We've got the resource data. So this is this struct at the top. This is what Terraform is passing in from the Terraform file. And this is how you get the entity ID and state ID. You may notice that I don't touch the rest of them. Terraform's kind of fine with that. You can define more resource than you actually use, and then build up the provider as required. And then we have this M interface, which is what Terraform passes about the provider. And here we just cast this from the M to the client, which I've just called C for laziness. And then we pass it through to the start light function, which is where we go away and create a light. So let's go and have a quick look at the start light function. In the order of this code, I obviously got a light before I could create it. I went into the API, went into it, manually created it. So getting a light is where I started with the API side of things. But for the Terraform, obviously we start with creating. So start light, we're getting in a light item, which is, if we go into models.go, it's where I've taken all that Terraform data structure and turned it into Go data structure. And then with the JSON stuff at the end, we're then turning it into JSON, which is what the API wants. The only one that doesn't have JSON is this entity ID, which for whatever reason, if I passed as in the JSON structure, it didn't work. So we're not going to pass that. And this is, oh, that was the wrong thing. I closed this one. And yes, this is a very simple Go calling a HTML method. We have the endpoint, which is API states, and the name of the entity ID. And then we're doing a post request with the URL, sending the body, and then we're doing some Go check to make sure everything works. Well, yeah, then we're trying to make sure everything works, setting the authorization to the client, which is the Beaver token. Just need to add to the header. Yeah, and then we're running it and making sure everything works. And if everything works, we just don't turn anything. We've just started light. We don't really care what we get back. We could use the body that we get back to then make sure the light works and return that object. But I thought it'd be a much more better idea to just call read. Let's spin up the light and then pull the infrastructure again, or pull the home assistant again, to just make sure that it has spun up correctly. But we'll worry about reading the state later. For now, we're just going to see if we can create a light. So we have access to the home assistant. If we go click the dots and then go overview, we can see the base dashboard. And we see there's no lights currently, but if we make sure everything's saved, go into Wetty, and then we build it, fingers crossed, everything will work, and we'll get another error. That's not the error I was expecting. That's fun. Okay, first thing first, if we get an error, check to make sure Go builds. So Go builds, and then the issue is body missing. Why is the body missing? Wait, 401, that's an authentication issue. That's my tokens not right. $.star missing. Okay, that's an interesting error. This always goes so smoothly until you run on the night. So I'm just going to check to make sure that everything's correct. So in here, we have a token. I'm just going to create a new token. This is the first time we use a token. Let's just make a new one. And then I'm going to go into here. I'm going to go into my TF file. I'm just going to remove this entire thing and replace it with a new one. So brand new token, brand new infrastructure. Build it. And it worked. For whatever reason, the token wasn't happy. Jobs are good. And now if we go to overview, we even have a light, which is turned on. Perfect. It's exactly what I want to see. Hopefully you guys are around the same spot. I imagine I've been shouted at if I needed to explain anything, or if people are having some groundbreaking errors that I can maybe explain on the screen. So yeah, we now have a light. If we go, well, yeah, we have a light, but Terraform doesn't know what to do with it. If we peer into our state file, we have a state file, but it's got this tainted status, which is because it doesn't know what we've done. So yeah, it's fine. We'll get to there. The next thing we want to do is we want to save the actual state. And we do that by using this read function. So this is how we ask Home Assistant, hey, what's our infrastructure like? So we're just going to do the good old copy, paste, and replace. And you see this looks very similar to what we just did. We make a client. This one, we actually care about the error. The last one, we didn't create a error body. We just return this other one, whereas in this read, we may return an empty error. Hopefully, empty error is a good thing. Empty error is always a good thing. So we can now, we set the light ID to what we think it is, what Terraform gave us. We're then using the get light function, which I'm just going to go and grab up. Which is in here. And then you see get light is very similar to the post light, the start light, not post light, start light. But the only difference is we're using the method get method, and we are reading the body because we actually care about the information that we're being sent. And if everything's good, then we turn the light body, we turn the body into light, and then we return it. Or we return it here, because if this one returns, there's an error. And in Go, even though we're returning the light, you can never really be sure what this would give you. Yeah, down here at the bottom, if all goes well, we're returning light and no error. And in the resources, we're setting the state. Yeah, we're then, let's actually remember the code. Yeah, so we just set the state to the light, and then that saves the state into Terraform, and it will be all happy. But currently, Terraform is not happy. As I pointed out earlier, the state is set to tainted, which means if you try and run it again, it's just going to keep being confused. That's the Terraform is very unsure what went wrong, what happened. So what we're going to do, because we're still messing with things and checking to make sure it works. We also have the benefit of Home Assistant. If it's there and you do another request, it will just update. If it's not there, it will then restart. So we can just delete the state and nothing really bad's going to happen. If you're making something for, say, AWS, you probably don't want to be deleting the state midway through, but it's fine for what we're doing. And then we're going to run the build again, and fingers crossed, we'll now, there we go. We have created light and everything succeeded correctly. And then if we go back to the light, it's still on because we didn't tell it to change the state to something else. We just told it to, well, do the same thing again. So if we look into the state file, which if you guys haven't explored a state file before, it's a very interesting way of seeing what Terraform's actually doing. This one's pretty simple because it's just the variables I'm outputting. But if you ever look into like an AWS one, you can see all the dependencies and how everything's interlinked, which is quite an interesting read, but depends how crazy you guys are. But yeah, you can see we have entity names and we have lots of other values that aren't used currently, but we may do in the future. So the next thing we need to do is we now need to update the light because we can create it and the creation works. So if now we say we just change, so we want to turn the light off. So if we just go off and then we go Terraform apply. Oh, if I can spell Terraform. This is why I built the shell script, because the shell script is easier than Terraform apply. So, oh, it didn't work because it's trying to modify and there's no update functionality yet. So if we go into our project Terraform long name folder and then go provider, home auto, and then resource light, which is probably where you guys already are. We can then update the update function. Yeah, so as you can see, this is almost exactly the same as what we've done before, except this time we're creating a light object. We're then running starlight, which was exactly the same as we did at the start to create the object. And then we'll make sure it doesn't error. And if it errors, we're reading the light. This is for the code we're dealing with. It is very similar to the create resource. If you were building something crazier or had a stronger API or a more complex API, you may need to do more logic and maths to make sure this update function wasn't breaking anything. So you can do some checks and maybe you'd call to make sure it works, make sure stuff's already there and how that works. This is very simple. So we can just send the update to, hey, here's a light we want you to do. So if you haven't already, if you want to change your main.tf to off, because it's not going to update if it's still on. So we then, you need to rebuild. We change some code. When we change code, we need to remember to rebuild. And this is why I've got it to Terraform init, Terraform plan, Terraform apply, because otherwise it's just too many steps. And we're on a mission to create a provider. So yeah, so now if we check the Home Assistant, the light's off. And if we turn it back on, and then run this code again, Home Assistant doesn't like it if you change things in different places. I don't. This is because this is a virtual light. There's not one of these in the middle. It gets a bit nickety about what you're doing. If you're using a actual light, the API code's a little bit different, which is why the end. I was hoping the ends of this I could click a button and go, oh look, the light turns on, but alas, I didn't have time to make that work because I only got this light like 5 hours ago, and that's not enough time. Okay, so we've got the light turned off. The last thing we need to do is we need to sweep up what we've done, which is going to be this nice handy delete code where we're going to use the delete REST API call. And the way that it should work for most things, and the way this home system works, is if you call the delete endpoint with the like ID of the resource, it just deletes it. You don't need any body. You can just go, hey, I don't need this thing anymore. And then if I go into here and go nope, I need to run the script. Always run the script. We need to build the code we've just made. And then if we go Terraform destroy, oh no, that doesn't work. I missed a step. Read me. So in the Visual Studio Code, if you are using Go and you get to this sort of situation where in the resources light.go file, we're no longer using FMT, and you save, it'll just delete it. Which means locally, you just don't need to worry about the imports. It'll just do it all for you. Because this is not Visual Studio Code, this is just an online code editor, it doesn't. And Go gets a bit iffy if you're importing things you shouldn't be. So I'm glad I remember that. So yeah, make sure you delete the FMT import in the resources light file. And then if we run the build again, it should all be successful. Our Go built all well. And then if we go Terraform destroy, nope, if I can spell DSTRY. And then we go yes. And then if we look at our light, it says it's not available. I have given you guys the code to change the color of the light bulb, but I'm not 100% sure it works, and scared of making even more of a fool of myself on camera. I shall leave that as a piece of homework for you guys to see if it works, and if it doesn't work, maybe tweak it a bit, see if it works. And I'll thank you all for watching and see if there's any questions. I think this has been, well, I mean, I hope you've been able to understand a word I've said. I know I've maybe been talking a bit too quickly, but yeah. Is there any questions? I'll suggest the Academy again because I really enjoyed it. It was a good time. I made a lot of friends during it. And I know there's a lot of people that want to get into tech and have maybe been down on their luck in the last 2 years since everything's happened. So it's maybe a good way of getting a change. But yeah. If there's no questions, then I will hope that the people sitting next to me controlling everything will put me out of my misery and click end stream. But until then, I'm just going to have to wait. He wants me to do a dance, and that's not going to happen. I've made a fool of myself too much on stream anyway. We're done. Cool. Thank you very much for watching, and we will see you next month for something else. Bye.